Theoretical yield refers to the maximum amount of product that should be produced in a chemical reaction. The amount you actually end up producing is called the actual yield. So to calculate the percentage yield, we do actual yield divided by theoretical yield multiplied by 100. Here's a question. 5 grams of methane reacts with excess oxygen to produce 10.35 grams of carbon dioxide and some water. Calculate the percentage yield of CO2. First, write down the balanced equation. Next, you work out the moles of the limiting reactant. In this reaction, that's the CH4. So to get the moles, we do mass divided by MR, so 5 divided by 16, and we get 0.3125 moles. Now use the equation to calculate how many moles of CO2 you'd get. We can see in the equation that 1 mole of CH4 reacts to produce 1 mole of CO2. So the ratio is 1 to 1. That means 0.3125 moles of CH4 will produce 0.3125 moles of CO2. Multiply this by the MR of CO2 and we get 13.75 grams. This is the mass we should be getting in this reaction. So this is the theoretical yield. But the question tells us that the actual yield was 10.35 grams. So to get the percentage yield, we do the actual yield divided by the theoretical yield multiplied by 100 and we get 75%. In any given reaction, the actual yield is hardly ever 100%. This is because some of the reactants may not fully react. Moving on to atom economy, which is about the percentage of the reactant atoms ending up in the desired product. To get that, we do the MR of the desired product divided by the MR of all the products, multiplied by 100. Here's an equation. NaCl is the desired product. So to get to atom economy, we do the MR of the desired product, divided by the MR of all the products, multiply by 100, and the answer is 98.3%. In addition reactions like these, atom economy is always 100%, since only a single product is made, and none of the reactant atoms are wasted. A low atom economy is problematic. They are less sustainable, especially since most raw materials are finite, and they're also costly, since more waste is produced, which means they need to be sorted and either recycled or put into landfills.